All right, welcome back. So in the last video, I mentioned there are two main strategies for traversing a tree: breadth first search, BFS, and depth first search, DFS. And these just refer to sort of the general order that we visit things. Are we going to prioritize visiting all nodes on the same level before we move down, or do we want to work in a more vertical way, which is what depth first is? So BFS, what we're starting with, breadth first search, just means we want to visit every node on the same level, every sibling node, before we look at a child. So for us, the order with this tree would look like 10, 6, 15, 3, 8, 20, and then we would keep going if there were more, from left to right in our case. But that part's not as important, the left to right. What's more important is just that we're working horizontally. Now I'm sure you're wondering, why would you use this versus another one? Why are there all these different orders? Why are we learning this? I will talk about in a separate standalone video, once we've gone over the different approaches, why you would use one versus the other, because it's a little hard to talk about it before you have the context of the other algorithms and how they work. So for now, I'm just going to punt on that and say, I'm going to teach them. If you have questions about why, let's just wait. I guess, technically it's a video, so you kind of have to wait, but just hang in there. The one thing I would mention is keep in mind, this is a small binary tree, but we might be working with a tree that is super, super deep and narrow, or something that's really wide. It doesn't have to be a binary tree. We could be talking about each node has 100 children. And so these different approaches, these different strategies actually have an impact, depending on what the tree looks like, how the data is distributed. Anyway, that's enough about the general approach to BFS. Let's get into specifics. How do we implement this? To do that, we're going to take advantage of a queue. So I don't recommend creating your own queue class and going through all of that. Just use a list or an array to model a queue, which, if you didn't watch the section or you don't remember, it's a first in, first out structure. So if we used a simple array or a list, you could just use push to add things in and then shift to remove from the beginning, so that whatever was added in first is always the first thing out. So here's our basic approach. We're going to have two variables. We're going to have the queue to help us keep track of things, and then we're going to build up a list of data to return at the end. So our end goal, if this was our tree and we're doing a BFS on this, breadth first search, we want to return this at the end. And our queue at the end will be empty. So the queue is just to help us out. So our main idea, we take the root and we add it to the queue. Then we loop as long as there's anything in the queue, and we dequeue a node from the queue, which, if you're using an array, just means shifting from the beginning of that array. Take that node and we add it to our return value, the list that we're going to return at the end. And then we check if there's a left on that node and we add it to the queue if there is. Then we check if there's a right and we add it to the queue if there is. And then we return at the very end after the loop, return the variable that stores all of our values. So if that sounds confusing, it is if we don't look at it visually. So let's walk through this briefly. So I have this is not really in a programming language, but I have a queue that I'm keeping track of, and then this visited thing, this structure that at the very end, I'll return this list or this array of data, and our queue will be empty. So we start with the root. We add 10 to our queue. This is like our list of, things we need to do. It's our to-do list. And then we start our loop, which just says, while there is something in the queue. So our queue has something. We're going to take it out. We're going to add it to our visited list. And then we're going to check if there's a left. Is there a left? Yes. So we add that to the queue. Then we check, is there a right? Yes. 15. So we add that to the queue. Then the loop starts over and we remove the first thing from the queue, first thing in, first thing out. So we take 6 and now we add it to our list that we visited. We have visited 6. Now we check, is there a left? Yes. So we're going to add it in. So that gives us 3. Is there a right? Yes. So we add in 8. And then we're done. We start over. We're not done. We're done with 6. And now we take 15 out. So hopefully you can see already this pattern, right? We're going this level, finished. Then this level, this level. And we're creating this queue to help us remember the things that need to come next, but we're not visiting them next. We're waiting to visit them until we finish a horizontal level, the breadth first search. So we take 15 out and we add it to our list that we visited. And we check if there's a left. Is there? No. Is there a right? Yes. So we add 20 in. And then we start over. We take 3 out. And we keep going. So there's no left, no right, so we don't add anything to the queue. Same thing with 8. We take 8 out. There's no left and no right. So we add that in. Then we get to 20. And now the queue is empty, which is how we know we're done. And we return this value at the end. This is our breadth first search. 10, 6, 15, 3, 8, and 20. This is how we traversed it. This is the order we visited things. So we take advantage of a queue to just store. It's like a to-do list. Like, don't forget this, come back. But we take things from the beginning and we add to the end. So the first thing in is the first thing out. Hopefully that explanation makes sense. This pseudocode is pretty clear, I think. So try and follow this and give it your best shot. In the next video, I'll have a solution.